conversation. This is conversation number 1 with Flat Earth Math and JibbyJedi. Jibby is an old friend of mine from, I guess it's been at least 2 years, possibly even longer than 2 years. And he and I had a very, very well-received debate where we actually had organized sets of points, and I made a bunch of PowerPoint slides. And we had a great debate followed by about 5 hours of just random conversations. So I would like everybody to give a warm welcome to my guest, JibbyJedi. So Jibby, please introduce yourself, and we'll just start chatting.
You have done well, Darth Flat Earth Math. No, how you doing?
Doing well, Jibby. Doing well. I confess I haven't seen any of the Star Wars movies since the quote unquote I guess the prequels, I guess is what they call them, episodes 1, 2, and 3.
That's horrible. That destroyed the franchise pretty much.
Oh my goodness. What I understand is, I saw episode 1 in Philadelphia on opening night with packed house. It was at the old Sam Eric on Walnut Street, which I think has since been demolished, and everybody applauded, when the Lucasfilm logo came on the screen. And it was just like, and there were people in costume. Here it was, Center City, Philly, opening night for the first Star Wars movie in, 20 years or whatever it was. And when the closing credits rolled, it was just mute stupefaction. People were like, what HE double hockey sticks did I just watch? And then I found out later that the movie was filmed in Norwegian, and it just was poorly translated into English. So it was much better than the original Norwegian. Like all the in-jokes did not translate well. So
it was a shame. And these new movies are not getting much friendly support either.
Yeah, well, my understanding is that the one right before the latest one, they had like a character named Admiral SJW. It was very, and then so I think Han Solo's son is emo or something. I don't know. I don't understand these things. Kids nowadays.
It's for a whole new generation. They're not giving service fanfare to the original fans. And
well, the thing is, George Lucas was an ingenious storyteller. And you can't take anything away. At least in my view, you can't take anything away from the original trilogy, episode 4, 5, and 6. Just genius. Star Wars, the original story, Star Wars was based on the hero's journey. The Joseph Campbell mythology. It was fantastic. There was a lot of depth there. You
really didn't get a lot of kind of religious aspects to it. Father and son and all.
Yes, well, that as well. But that's all wrapped into the hero's journey as well. But the reason why it resonates so well is because it's timeless. It's a timeless story. So, and Hillel Finder's in the chat. He says, "You're one to talk Star Wars. Sith Lords are my specialty."
Well, I know you're a big Star Wars fan because, we have this. Like that's kind of proof right here.
This is true. Yes, you weren't supposed to show that, but that was. Oh my goodness. But no, I haven't followed. I haven't followed the latest movies. I don't even know the names of the movies. Somebody says, "Oh yeah, did you see XY?" And it's like, is that a Star Wars movie, or I don't know. But
it's going to get to that point where we're going to say, is that a Star Wars movie? Because they're just this story, this is a Star Wars story, this is Star Wars. So they got a whole bunch planned. Obi-Wan Kenobi, solo story. I guess his adventures on Tatooine or whatever. It's just, I'm not looking forward to it.
So, what's the topic of the day? So people have been talking about flat Earth and perspective. Have you been following the Nathan Oakley Viper Pit shenanigans?
Well, since you were on that day, it's been brilliant.
Oh yeah, that's right. Yeah, because you excerpted that conversation.
I highlighted the very heartfelt admission
where the first words out of my mouth are, "Nathan, you're very upset."
I tried to get it to start it at a spot that wasn't too something. I don't know. I thought that was a good spot to start it, but
yeah, no, that was very appropriate because it was, you know, the voice of reason trying to talk down off the ledge the deluded man. But no, Nathan's a good guy, but he's, you know, he's sincere in his belief. I didn't used to think he was like a flat earther. I thought he was just sort of playing along like for a lark, but he's gone whole hog, and he's like to the point where he's actually angry that people know the earth is a globe. So
I don't think that's why he's angry. I think he's angry because he's had 306 shows of Trollfest. And eventually that will get on your nerves, and you just don't have that polished tolerance anymore.
You mentioned that, but the thing is, and I don't know, like if a Martian came down, doesn't know anything about the flat Earth debate, and just watched the tone, watched the behavior of the participants. I mean,
out of context, yeah.
But you know, yes, out of context. But it's like if you see only one side doing the shouting, only one side muting the other, you know, muting the opponent or booting the opponent.
I know what you're saying, but were you there at the beginning of this? That's all that was happening to flat Earth researchers, was the muting, the shouting, the yelling, the cursing, the word retard being thrown out constantly, while we were the calm, cool, and collected. Now that we've been so warfare trench like driven, we are kind of with that scrappy attitude now, where as soon as somebody pops in and says, hey, the earth ain't flat, that's it, we got weapons out, shields, like we're just ready to go back to battle again. It's just something that happens to, I guess, your personality when you're dipped into it for so long and you receive so much ridicule. I mean, like we all say, we don't want to be flat earthers. It's like, oh yeah, I don't mind getting rid of my friends and family and being estranged by society and ridicule constantly. That's absolutely what I want. Oh, I feel part of a group now. Oh, I feel so welcomed. Like, no, it's like a curse. Well, it's terrible.
I totally acknowledge that, and that was a fantastic article. Was it in the Boston Globe? But you know, it was a sensitive portrayal, you know, of you know, the tale of one flat earther. And I mean, were you pleased by that article? Do you think it was fair? It was a fair treatment, do you think?
I think it was a fair treatment of the flat earth topic, and that's all I concentrated on with him was, please report it accurately. And we told him the curvature formula at least 1,000 times, and he said it wrong in the paper. So he said that was done, and he said that was done in the editing process, and he would check into why it was done like that, but he never got back to me.
Yeah,
but that was the only part that I had a problem with. The rest about me, nonsensical, doesn't matter to the flat earth. My life, I mean, you can look at my experience, what I went through in a relationship that was slightly exaggerated for you know, drama purposes. Like, but other than that, she was actually supposed to come on and make some corrections to that, but she's very shy and doesn't go on camera, Mike. Other than that, I didn't care how they painted me, as long as they didn't paint me as like a terrorist type, a lunatic. I let him come in my home, so he could, you know, do his reading. You know, he always says, like, when he does these big long articles on people, he likes to meet them personally, like in their home, check out their environment, because you will know a lot about somebody that way. You see where they live and everything. And I was hesitant, and I said, yeah, you know, after months of this, working on it with him, I'm like, you know, if this will speed it up, get it out there, report it fairly, I'll throw myself on the grenade and dox myself and all that. Sure, come on out, whatever.
Yeah.
And it still turned out okay. So I was amazed at that. But
so
it was okay. It was fair and neutral, but it was a personal story. What do they call it?
A human interest story.
Human interest story. Yeah. Yes. It was more of that than any kind of flat earth proofing.
Well, the reason why I bring that up is that I do not insult people in the flat earth debate. I you know, like occasionally I'll get a little snarky, and I think you've seen that side where, you know, where somebody's coming on super strong, and I'll kind of maybe have a little bit of a tone about me. But, you know, I won't call people names. I won't use profanity. I try to be a gentleman. I try not to interrupt, although sometimes if like the first few words out of somebody's mouth it's clear that there's a misunderstanding, that's when I try to interrupt, because it's like, I don't want the guy to go off for 5 minutes, and it turns out that like the entire point was a misunderstanding. but I try not to interrupt, except, like in that circumstance. But having said all of that, when I go into one of these flat Earth debate shows and I'm treated, like the sludge monster from the Poop Lagoon, and I'm treated like the most vile of vile creatures, and I'm called every name in the book. Like it doesn't seem that, okay, yes, you've been beaten down by some people who do call you crazy and who they do call you a liar and they do insult you, but I'm not doing any of those things. So why would you treat me, like that's the thing I don't understand.
You're absolutely right. And that's why I took a particular liking to you. One of the main things I did anyway, what I liked about you was that you didn't fire back, and even my friends were very rough on you. And I still got the hangouts on my channel from 2016. I'm like, hey, let him talk.
Right.
Like they were very unfairly berating you, but they're doing what the globe earthers do to us, and they paint with a wide brush. And I try to treat people individually. Like, oh, this particular individual likes to call me retarded. This individual likes to call me a liar. I'll address them according to how they address me. And then you treat everybody as they treat you. I can't say I walked in Nathan's shoes to know his perspective doing these shows with all these trolling and just constant sniping every episode. And it's going to build sour apples, It's going to build just this disdain in you or anybody on that side of it. And I can't speak for Nathan. I just can't. I know.
Sure.
I wouldn't be very nice in that situation. I would probably be a little rough around the edges. And yeah, it is unfair. It is unfair. You don't deserve it. And even Bob said today in Patricia's, you're one of the most pleasant globe earthers, despite your unfortunate beliefs. You are.
Unfortunately. But the thing is, if you go into a debate, you have to acknowledge that you're going to have an opposition. Like I'm going to debate for the color green, and my opponent is going to debate against the color green. That's the starting point. So I don't understand that it seems that some people are like, well, if you are debating against the color green, then you're evil, and then you've been paid to debate against it, and it's like, well, why go there? Like, why can't we have like an actual debate, like even if I were playing devil's advocate, like Bob from Globebusters, he's always saying Chet's really a flat earther. And that's funny, but even if I were playing devil's advocate, you wouldn't, be viciously attacking your opponent. You try to engage the person on the topic, the issue. So I don't know.
I don't attack you. I never did.
Oh, no.
I do like to, what's the word? Roast you.
Yes.
I roast everybody, though, flat earthers especially. But it's just that's me. That's my personality.
So I hope to start a series of conversations, and I think I indicated to you, and maybe I didn't make this explicit, but that this is going to be a 1 hour show. I'd like to have a regular series of these things.
Yeah.
So
I have no idea what we're talking about.
It's a conversation. This is not, it's not a debate. Like I literally don't have any slides. I literally invited you 2 hours ago.
Yeah.
The audience has no expectation other than it's just a chat between me and you. So, we could talk about anything. But what I would like us to do is to not dwell on one topic for too long, because when it comes to 10 o'clock, we're going to be like, okay, folks, thanks for showing up. And I'm going to click, stop broadcast. Just
the flat earth is, we're out of time. Tune in next time, folks.
So Jibby, what do you see as being, something that's big, one of the big topics that you would like to discuss? I'm open to discuss anything.
Illusions, fakeology. Maybe you could say it's a whole fakeology around things. Last night we actually, I don't know if you probably haven't heard this, but it was late last night, probably about 10 o'clock. Have you ever heard of WEEI, National Sports Talk Radio?
No, I have not. I'm not a sports guy.
Me either. It was on in the radio in the kitchen. I went down to get some water and I hear, "The earth is flat, ... was his tweet." Now, what do you think they're going through their heads on the Celtics here? And blah, blah, blah. This guy's like contaminating the Celtics. And I'm like, oh, of course I had to hear this.
Okay.
So I get on Poncho Pete's. I put in the chat, like they said, hey, anybody, tell me your comments on this flat earth stuff. Don't do that. That's no door. So I put the number in Poncho's. Jared Wiley, wild guy, whatever. He calls in. And he sounds like your typical sports fan. He's like, "Hey, Ben, how you doing? Yeah, it's Kyrie Irving stuff, whatever." And he flat smacked him pretty good for probably about 2 minutes. There's most of it I got on the air on Poncho's. It's on his last night's show. So
hold on a second. What does flat smacking mean?
That means you're just dropping a whole bunch of flat Earth evidences on them.
Oh, okay.
We see farther than we can. Stuff like that. Water is flat level when at rest. Contain, all the stuff that we say. And he drops, some quick ones in there. And the guy gets kind of like tongue-tied, and he's like, and I think he dropped him, and then hits the X-Files kind of button to trail him off, like, cuckoo. Right. And that's kind of what we face all the time. We face that kind of ridicule regularly. But it got on national.
But you exposed
radio.
A few people to a few things that may get somebody wondering. Like, oh, maybe I should look into this. Water never curves.
I'm not trying to say believe me, or I'm not. I'm saying you have to convince yourself, because if there's a lot of flat earthers out there who I call they're flip-flop earthers, and a good word salad, and they don't know if it's concave now. They just don't know. They're like, I need somebody to give me a good presentation to reconvince me that those people are not, I don't know, they're TV watchers. I don't know what you call them. You have to do this stuff yourself to prove it to yourself, or at least as strong as you can prove it to yourself. Then you've done the work, and you don't really care who's a shill or who's saying something. You don't care, because it really doesn't take anything from the information that's out there, the experiments, the results.
Right. So when I was asking for topics, you said fakeology or something. What does that mean?
Well, it includes NASA too and all the space stuff. But Charles, have you noticed these fake stories out there that kind of like promote fear?
You meaning like we're getting away from flat Earth, like fake news, like that type of stuff?
Well,
it's all part
of the umbrella. It's part of the umbrella of flat Earth. Yeah. It's all under there, fake nukes, fake all that, and we can talk about fake nukes for another hour sometime and get into slideshows.
Looks fake, therefore is fake.
Well,
but my father,
if Bugs Bunny doesn't look fake, that's a different story. But Bugs Bunny looks fake, therefore he is.
Well, Bugs Bunny was based on a true story.
So he took a wrong Kirk in Albuquerque.
My dad worked on inertial guidance systems for ICBMs. So he has he passed away a number of years ago, but I asked him, I guess it was maybe 30 years after, he'd worked on this stuff. I was like, well, what kind of accuracy did you guys get? Because this is obviously before GPS had been invented. They were just literally using gyros. And he said, like, the first words out of his mouth is like, I think it's unclassified now, because like he didn't want to give me a straight answer right away, because he thought like literally what he was saying might still be classified. But he's talking about Cold War era missile technology. So finally he said in their tests, and they would fire missiles into the Pacific Ocean and have it land on a certain grid coordinate in the Pacific. They said they got to within like 100 yards, which was pretty amazing, just using gyros, And the thing is, those gyros were called space gyros because they were three axis gimbaled gyros, unlike what you have in a plane. And I thought that was pretty impressive, because obviously you have to take curvature of the Earth into account, because those things literally went into space before they came back down. But so yeah,
at least on paper they did.
Oh well, that's what I believe. I think that's what the evidence says. But getting back to flat Earth, are there any flat Earth topics? Because I would like to focus on flat Earth. I mean, because there's a ton of other things we could talk about, and I would much prefer like the flat Earth issues.
Okay.
Like, what's your take on perspective? Or I don't know if you've...
Oh, there's your curvature math right there. I mean, and I like how Nathan put it today. He said it's called curvature, like the curve calculator.
The Earth curve calculator.
Yeah, it's like saying, here's we're going to do a globe Earth test. It's already got a pre-assumed little adjective in there. It's a curve calculator, so it sounds like that calculator is going to curve no matter what. It's a curve calculator.
Well, one of the things that I've run into, especially with Nathan, is that it's hard to have, like, one of the things you'll find me saying in that conversation that you excerpted is, I would love to have a conversation with you. Because when you have a conversation with somebody, you're not trying to prove a point with every sentence. So one of the things that I find with the folks in the debate is, like, a globe Earth person can't just say something without somebody else saying, well, that doesn't prove the Earth is a globe. And it's like, well, what if the person wasn't trying to prove the Earth as a globe with that sentence? So when somebody uses the Earth curve calculator, oftentimes people say, well, that's begging the question. So, you're using the Earth curve calculator to prove that the Earth is a globe. And it's like, well, what if you're not trying to prove the Earth is a globe? You're just trying to discuss this calculator. And so one of the things that they feel that they got this thing over on Mick West was that the assumptions built into the calculator. One of the assumptions is that the Earth is a sphere with a certain radius. And then it goes from there. They also assume that standard refraction is, I don't know what 7/6 are. So there's certain things that are baked into that calculator. But having said that, the calculator just runs the numbers. I mean, it doesn't, like, the calculator isn't like, oh, we're going to try to convince people the Earth is a globe. It just takes the input and it just runs the numbers. Like, one of the things that I would like to do in a future video is literally go through just like a Google spreadsheet, because then everybody I could share everybody on it, and literally live, well, not necessarily live like a Hangout live, but make a video of me just clicking on the cells and building an Earth curvature calculator. Because it's just math. It's literally just geometry. It has nothing to do with the planet Earth, believe it or not. Because one of the things about the Earth curve calculator is you could put in any radius you want. Like, that's behind the scenes. It's not one of the upfront numbers, but, like, you could make a basketball curve calculator. You could just put in the radius of a basketball and it will calculate all the numbers.
How come we don't have that math for the Earth, though, where if you calculate the curve of a basketball, each little section of the pie is the same exact thing, but yet with the Earth calculator, we got to do 8 inch per mile squared, and then it's cumulative and whatever. Why can't we just have this section of every 10 miles or 20-mile chunks, there's this much drop, and then kind of do it like, we do with circles and geometry and things like that? Like, why can't we just do that with the Earth? Why is it this different kind of math?
Yeah, no, it really isn't different. I think that there is some misunderstandings. Like, for example, the 8 inches per mile squared, a lot of globe people have been attacking that formula, even though that formula was not invented by a flat earther to attack the globe. It was actually invented by globe Earth folks, 200 years ago, because it's a very, very good approximation if you measure the distance as the chord. And what the chord is basically, if you have Chicago, and then you have Rob Skiba across the lake, and just draw a line between Rob Skiba's feet and the foot of the Sears Tower, right? Well, that line is actually going to go underwater. That straight line that goes between Rob Skiba and literally the base of the Sears Tower, that line is going to go underwater. Well, and if you measure that as the distance, that's called the chord. It's like the straight line distance. So if you measure the distance as the chord, the 8 inches per mile squared formula is an amazingly accurate estimate of curvature drop.
And it can only be used only until you get to where the drop now starts to go the other way at the equator or whatever.
To a quarter. I mean, like, who measures Earth curvature more than 1/4 the way around the planet? Like, that literally doesn't make sense.
It is trying to see if it's a globe or not.
The thing is, the assumption is that it's the globe to use that formula. That's the other thing, is that sometimes people are yelling at me. They're saying, well, you're begging the question because you're doing all this stuff with the Earth curvature formula. And I'm just like, all right, well, if you don't want to assume the Earth is a globe, let's back up a step and we can figure out what the shape of the Earth is. And every time I mention that to Nathan, he starts screaming at me because it's like, it's established science that the Earth is a globe. And it's like, well, you could literally throw established science under the bus and you could figure out the shape of the Earth. Throw Mick West's calculator under the bus, like just throw everything out. And all you're starting with is a blank slate with zero assumptions, but you're allowed to observe. You're allowed to make measurements.
Right. Oh, let's expand upon what you said at Nathan's. You said, I have no proof. I cannot prove the globe Earth.
Well, you're misquoting me slightly. I said scientific proof does not exist. All right. And that's a very, very, maybe it's subtle. Maybe it's on the philosophical level of like, what is knowledge? What is truth? But scientific proof, and you can look this up, scientific proof does not exist on any topic. Like you could literally hold up your hand in front of the camera and say, I have 5 fingers. I'll be like, okay, I can see you have 5 fingers. I'll believe you, but you wouldn't be able to scientifically prove that you have 5 fingers. Because, you could be holding up, you could have lost your pinky, in the war, and you could have a prosthetic pinky. Therefore, you're holding up what looks like 5 fingers, but it turns out the pinky's fake.
Now you're talking NASA right now.
Right, but do you see what I'm saying? I mean, you could play games with this. I mean, you can go to the extent of like, we could be living in a simulation, and you can't disprove that we could be living in a simulation. We could actually be living in the Matrix. And what I always say to that is that, if we are living in a simulation, it's a heliocentric one.
Oh, but it's so inefficient that way. And it limits the expansion programs. Like you would get a normal multi-online player game that's already written. When you beat the game, they come out with expansion sets for new lands, new adventures.
Are you saying we can't explore Mars?
It's done.
We can't explore Mars. We can't explore Venus. We can't.
We're not. No, we can't. Well, at least we can't unless we're white, Freemasons who go to other realms, and those things are other realms. Then maybe. But
no, I'm saying about the heliocentric, like the heliocentric model, where space is not fake. Where NASA is actually doing exactly what it says it's doing.
Oh yeah, they're kicking the can down the road nicely. Yep.
But the point I'm trying to make, and getting back to your question, is that scientific proof does not exist. So that could be used against me saying, oh, Charles just admitted that he can't prove that the Earth is a globe. And it's like, I cannot scientifically prove the Earth is a globe, just like no one can scientifically prove the Earth is flat. However, we can have scientific evidence, in which case about 100% of the evidence shows that the Earth is a globe and 0% of the evidence shows that it's flat. So I can give you scientific evidence all day. Now, I have noticed something about Nathan's show is he's been using the word proof less, and he's been using the word evidence more. So it's like, I think he's turned a corner there. Because he used to say, prove R, prove R, prove R. Like every time I would, make a comment or whatever, he'd be like, prove R, Charles. And then now he's starting to say, give scientific evidence for R. And I think that's a huge positive step. So
give scientific evidence for how you can weigh the Earth.
No. Well, the thing is, if you don't understand the Cavendish apparatus, which I would say 90% of the people in the flat Earth debate don't even understand the apparatus.
Well, we do understand the garage model. Yes. Well, the garage 200-year-old Cavendish did it in his garage model. Yes.
Well, no, see, that's a cartoon. That's a cartoon. That's like the spinning ball. It's like, if you can't say planet, you have to say spinning ball. Well, you've just now made your opposition into a cartoon. So, 2 balls in a shed. That's the standard line about Cavendish. 2 balls in a shed. Ha, 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 ha. Well, that's not actually an argument. If you actually read Cavendish's paper, it's available online. You get a PDF of it. This guy was a true scientist. My understanding is he was sort of a bit of an eccentric. He didn't really have social skills, but I think he was rich and he was very interested in science. So he was able to afford to purchase like the best equipment. But he did have a mind for science. But if you actually study his apparatus and his methodology, it now becomes less cartoonish than 2 balls in a shed. You actually can see that he was making a measurement, making a very careful measurement.
And we can't improve on that Cavendish. And it's always referred back to.
Who says
well, where's the modern version of Cavendish?
Well, the modern version is done in physics laboratories, and at the university level by freshman level experimental physics students reproduce it all the time. There's actually a little model. It's I think $1,000 from the scientific catalog, but with the two balls, and you can counter rotate the external weights, and so people regularly do it.
Okay, that's it. Those are the only objects we can use to prove the Cavendish?
Not the only. That was the first one I mentioned. But the thing is, when people talk about Cavendish, they don't mention him because he was the only guy that did it ever. I think there was a guy named, I don't know, C.V. Boyes, like 100 years later, who used, I think, fused quartz for the torsion. Like, when you have a torsion balance, you have to have like some kind of a string or a wire that the thing is hanging from. And this guy, I think his name was C.V. Boyes, he improved upon Cavendish's apparatus by using something like fused quartz for the torsion. It's like, he took it to the next level, and that was 100 years later. So it's still in ancient history, but the apparatus gets better and better. But people talk about Cavendish not because he was the only guy that did it, but because he was the first. And that's the thing that a lot of people don't realize. They're like, oh, this is before the invention of electricity, 2 balls in a shed, ha, 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 ha. And it's like, it sort of betrays a lack of knowledge about what actually the apparatus was.
But did it prove gravity?
No, it did not prove gravity. It absolutely did not prove gravity. It was measuring a force that is proportional to masses and inversely proportional to the square of the distance.
And static electricity isn't in there?
The thing is, static electricity, you may have heard of the name Coulomb.
Yes, and have you heard of Coulomb? Yes.
Oh my goodness. Are you doing one of those flat earth things where you just sort of talk
I'm
nonsense?
about to flat you on something.
Oh my goodness. Coulomb, what people don't understand about the Cavendish apparatus was it was first used, or at least it was earlier used by Coulomb, I believe almost 100 years earlier, to measure the charge on an electron. But people don't have any problem with that. They use electricity, so they don't have any problem with electrons, but they have a problem with gravity. But the thing about the apparatus was that it was sensing a force between masses that was proportional to the product of the masses and inversely proportional to the square of the distance. Like, that's it. Like, that's what it was proportional to.
Here's the 2 equations right here. One of them is the Coulomb's law, and the other is the equation for gravity.
Yes. But you find a great many. Let me. I don't know if do I click on it.
The
thing is, if I click on you in Hangouts, I want to have that stay on the screen, or can I turn on, or can I have you use screen sharing, or does that something?
You would have to share controls with me. You go down to the 3rd icon on the left, the control room. You click on that.
Okay, hold on a second. I clicked on the wrong thing. The 3rd icon on the left. Oh,
the blue, the green, and then the little.
The one that looks like a little control room. All right, click on control room, and then
my name will be off to the right. Now, all the way to the right of that, you'll see a little arrow.
It's a drop-down menu. Share controls. Oh, I'm going to click the eject button just because I don't like the way this is. Okay. All right. You now have controls.
Okay. Now this is Coulomb's equation.
Yes.
And the other is the equation for gravity.
Oh, it's still showing my globe thing.
Oh, you clicked on yourself. That's why.
Okay. No, I'm actually on the watch page. I've got the watch page open. All right. So now I've clicked on you. So, but the thing is,
what's the difference in these 2 equations?
They're very symmetrical.
They're exactly the same.
They're not exactly.
The letters are arbitrary.
They're not. The letters are not arbitrary because Q is not the same as M.
The Q. What does the Q stand for?
I'm assuming an electrical charge. But
charge
I'm
1, charge 2.
I'm not familiar with that equation, but I do know that there's
times charge 2 of the distance squared. This is mass 1 times mass 2 of the distance squared. It's basically, I dare hypothesize, they're basically trying to say or equate matter with electricity. Now we're getting into VR again, where all matter's electricity here, maybe.
Or and one of the things you learn when you study physics is that units reveal the mathematics. And what I mean by that is the force. Like if the left side of both those equations is force. So let's say we'll call it newtons. A newton is a measure of force, but like, in English units, we could say pounds, like you step on a scale and the scale reads 200. So you're putting 200 pounds of force on that scale. But in physics, we usually talk about newtons. Well, newtons has a very specific definition. And if you look at the units on the right side of the equation, and the thing is, I don't know what the units of G are. I guess it does say there, Newton meter squared over kilogram squared. That will actually give you the units that are in the force. And I should have studied up on this, but the thing is, you'll find these symmetries. So, for example, do you know what the formula for kinetic energy is? I think it's F equals 1/2 mv squared. Does that ring a bell from physics? Wow. I think that's.
I slept for most of physics.
Okay, so easy. I'm pretty sure this is just going off the top of my head. I haven't done this in years and years, but I think the formula for kinetic energy is 1/2 mv squared. Okay, so 1/2, that's just a number, that there's no units to the number 1/2. M, so that you have a mass, say kilograms. V squared, so you have say meters per second. So it would be like meters squared over seconds squared, right? So meters per second quantity squared. So mv squared. Well, then you take a look at Einstein, and he comes up with this wonderful equation, E equals mc squared. Well, what's E equals mc squared? What does that remind you of? Well, it's kinetic energy, because it's mass times velocity squared. Now the mass is the mass of the thing in question, whether it's a paperclip or a spaceship, but then the velocity is the speed of light, which still has units of meters per second. So you're still squaring that. So when you study physics, you learn about something like kinetic energy, 1/2 mv squared, F equals 1/2 mv squared. I'm sorry, E equals 1/2 mv squared. And then you also learn about Einstein's famous formula, E equals mc squared. And it's like it's the same units, which is why the formulas look the same. Does that make sense? It's not the same formula, but it looks very, very symmetrical because the units are symmetrical.
Math is a good way to try to explain observations, and doesn't necessarily prove the things that we're observing are what they claim to be. It just kind of works out on paper. And when we're dealing with the lights in the sky, yeah, they have a kind of like a calendar clock-like trackability to them. That doesn't mean that they are the things that they're claiming, especially when the evidence is real evidence is so not there, and it should be. So then you turn to the paper facts and the math. Well, it works out there. Now the sun's starting at 3 million miles, changing to 93 million miles. That's a big change.
Right. Well, it sounds like a big change because it's like, so many millions of miles. But if you think about the sun going from a really far distance away that we can't really accurately measure to a really far distance that's maybe, 30 times bigger that we can sort of accurately measure. Like, what's the difference between a really far distance and then another really far distance that's 30 times bigger? Like once we get the means to measure it.
Right. It's like they found something else that didn't work with the 3 million, so they just bumped all the numbers up.
No, but the 3 million was never a serious number. I mean, it was serious.
The 10 million or the 13 million, they changed it several times.
No, it's not they changed it. It's people were estimating. The problems with the early estimates for the distance to the sun is they were trying to triangulate something that you can't triangulate to. Like triangulation is, you carefully measure angles, and then it's like, if I know this angle and I know that angle, well, then where the two lines meet, it forms a triangle. But if it turns out that I'm measuring this angle over here and you're measuring that angle over there, and those two lines are essentially parallel, well, okay, so your triangle is going to be super, super huge. And it's like, well, is it a 3 million mile tall triangle, or is it a 90 million mile tall triangle? So you can't really triangulate something that is an extreme distance away. It's like the triangulation process breaks down as soon as the two lines become parallel, or at least essentially parallel. And so that's what those early guys were doing. And it wasn't until the transit of Venus that they actually had like something to hang their hats on.
And do you think this 93 million miles is the final accurate number? Like they hit a laser against it, it's kind of thing. They landed on the surface of it. Like it's still an estimation.
Well, no, what you don't understand, and this was a top secret NASA program. They actually landed a lander on the sun, and they installed.
I think that was Korea.
A retro. They put a retro reflector on the surface of the sun, so they could bang.
It's still there now. It didn't melt.
Hit it with a laser. So you asked about the 93 million miles. Well, it's like, you say 93 million, but if you actually look up what the number is, it's actually 92 and change. And sometimes it's, it maybe even rounds up to 94 and change.
That's the story of astronomy. Try to get two people to say the same thing. You can't.
No, what people don't understand is that for starters, the Earth is in an elliptical orbit. I mean, it's really close to being a circle. But it's elliptical by, I think, 4% or something.
Does that mean we're changing speed? Do we change speed at all?
Yes, we do.
So we should feel acceleration.
No, we should not feel any acceleration because we're in free fall.
Well, I don't understand that. If we're at a constant speed, it's one thing, but once you accelerate, you should feel it.
So, the thing is, you probably have a smartphone. I don't know if you've ever played with these accelerometer apps. They just tap into the accelerometers that are built into every smartphone. And so we all know that it's 9.8 meters per second squared. Now that's the acceleration due to gravity. And so a nice little thought experiment is you take your phone, you turn, you run an accelerometer app. And then you turn on like logging or something, like you turn on record. All right, record now. And then you can shake your phone around and you have it record all the forces. So here's the question. This is a thought experiment. You put a nice fluffy pillow on the ground. You take your phone and you hold it over the pillow. And then you're recording, so it's recording data. You let go of the phone. Well, of course, the phone is going to accelerate at 9.8 meters per second squared. Like you could photograph it, with a video, and you can analyze the video. It's free fall. It's free, free fall speed or free fall acceleration. You're with me, right? Okay. So you just took your phone and you dropped it onto this fluffy pillow. The question is, what is the phone's sensors going to register? Is it going to register that it was accelerating at 9.8 meters per second squared? Because it was. I mean, any objective observer would be able to say, I saw that phone accelerate at 9.8 meters per second squared. So Jibby, off the top of your head, and I'm not trying to play gotcha, do you think the phone is going to record that it was accelerating at 9.8 meters per second squared?
Based on wind speed?
No. You're in a room. You just dropped the phone.
It's connected to everything.
You just held the phone. You held the phone, and then you dropped it, and then so it fell, 3 or 4 feet onto this pillow. So when it was in the air,
by figuring out your actual location, whether that be on the ground or in the sky, and then estimate the rate of speed that you're going and when you'll probably reach the ground. I guess that's how they would do it.
Yeah, but I mean, would the phone's log? The phone was recording the accelerometers. Would you say that it was recording that it was accelerating at 9.8 meters per second squared?
Yeah, I don't really have too big of a problem with that.
Okay, so the thing is, I would agree with you because that's what common sense tells me. If the phone is actually accelerating at 9.8 meters per second squared, shouldn't the log reflect that? And the answer is no. The answer is it will record 0 acceleration, which is like, wow, that's a head scratcher. Because when you're in free fall, you experience no forces, right? You experience no acceleration. Even if you are accelerating, you don't experience it. So when we're orbiting the sun, yes, we speed up a little bit when we get to, perihelion. We slow down a little bit at aphelion. I think I've got those numbers or the
when you're talking apples and oranges, because you're talking about dropping a cell phone in an atmosphere.
But we're in free fall around the sun. I mean, I always hated that phrase, but it's actually true. We are in free fall around the sun, which means that even though we're speeding up and slowing down very, very slightly, we're not going to feel it. Like the most sensitive instruments on Earth would not be able to sense that acceleration or deceleration.
But you're talking about in a vacuum. Like, and the forces, you will have forces on you if you drop the cell phone. You're going to have wind friction.
Well, all right. So,
all that.
so let's say you were dropping your cell phone in a vacuum chamber. Like, let's say you did that bowling ball vacuum chamber thing, but they held up a cell phone, and a big fluffy pillow. Do you see what I'm saying? With landing on a pillow. You know the thing I'm talking about. Brian Cox, the big vacuum chamber, right? Yep. So if you dropped a cell phone in that vacuum chamber, so there's no wind resistance whatsoever, the cell phone would record 0 acceleration. All right. And people don't understand that. But like, you could literally try this with your own phone. You could drop it onto a pillow and you could try it. I mean, you obviously not in a vacuum chamber, but air is pretty thin. You're not going to get too much air resistance at low speeds. So I don't know. What were we talking about? I have no idea what we're talking about.
NASA fakery.
Oh, NASA fakery. Yeah. And I'm going to say something because I always trigger people with this. NASA has never lied to me. I've never known NASA to lie to me, except for the global warming stuff. But that's another topic.
Okay.
But they weren't really lying. They were just interpreting the data.
How do you know?
Yeah. So I go with the evidence. I mean, this is the thing with the moon landing. And I know you're a big moon landing guy. You're a big space shuttle guy. It's like I go with the evidence, and I've just never seen any evidence that was able to withstand scrutiny. Like that's
all right.
That's huge.
Have you ever heard of Echo 1?
Of course, I've heard of Echo 1.
Okay.
Do you know how high they went with that?
1,000 feet.
No, 1,000 feet, 1,000 miles.
1,000 miles. Yeah,
it's 1,000 miles. Which
it should have went 1,000 feet, but it went 1,000 miles.
It was not a balloon that was buoyant. It was a balloon in the terms of it was a gas-filled bag, but it was a satellite. All right.
Gas in this thing, yes, and it's self-inflated.
Yeah. They had a little canister of
a little canister blew up. A little canister.
Well, I mean, because it's in a vacuum. I mean, you've seen, Jibby, you've seen those things where you take an empty balloon and you tie it off and you stick it in a vacuum chamber and you can inflate a balloon with nothing in a vacuum chamber. So,
and it was very thin mylar.
Yes.
A quarter centimeter, millimeter, I don't know, very, very thin. They actually claim self-healing mylar, whatever that is.
Magic. Is
magic. Like the magic parachutes on Mars.
So what were you getting at with Project
I just don't understand how this maintains. Now, do you see any engines? Do you see any?
No, it was a satellite. I mean, obviously
they popped out there that happens to be in that Goldilocks cherry zone where no gravity pulls it any direction. It stays right where you put it.
There's no such thing as a Goldilocks zone. That's something invented by people who don't understand gravity.
It's basically the gravity. The way I understand it is wherever you drop something in space, it'll go exactly where you want it to go all the time, and it doesn't need any help.
Well, what you have to understand, and I didn't get this when I was a kid, because when I was a kid growing up, and I knew that there were astronauts, and I knew that you could see the movies of them, like floating around, and so I knew there was zero gravity in the place where astronauts did their thing. Okay, but what I thought is that they were in zero gravity because they were so far away from the gravitational pull of the Earth. Like, that's what I thought. I also thought that rockets went straight up. Like, it wasn't until I was, I don't know, a late teenager or something. It was embarrassing how long it took me to figure this out. But I just thought rockets just went straight up. And then as soon as you got far enough away from the Earth, it was like, okay, you're in zero gravity. And it wasn't until, I don't know, I think maybe the space shuttle that I really started seriously looking at this stuff that I've discovered that no, it's actually microgravity. It's actually the centrifugal force is canceled by gravity, or gravity is canceled by centrifugal force. And, so it really is sidewards velocity, 17,500 miles an hour. And then it turns into a physics problem as opposed to this mysterious, you go, and then all of a sudden gravity disappears, the Goldilocks zone.
Do you know offhand, when the concept of a vacuum, was even thought up?
Well, I mean, people understood, I think even, I don't know, probably hundreds of years ago that, they knew that when they tried to go up to a tall mountain, they had trouble breathing, and, very simple apparatus showed that the air pressure was less. And so I think I'm not sure when exactly they figured out, the dynamics of
about
our atmosphere.
350, 400 BC.
Well, I wouldn't go back that far, but I mean, as far as like, like the air pressure on Earth as being a cause of Earth's gravity on Earth's atmosphere. I don't know how old that is, but I'm sure it's probably, at least several hundred years old. But that's another thing, is that it's people are talking about how can you have atmospheric air pressure without a container? That's one of Quantum Eraser's favorite lines. How can you have pressure without a container? So his idea is that there's a dome. We're in like a snow globe, but then the question is, well, how come you can get near zero pressures at the top of this, what we would call space? Because you could send a balloon up there. I mean, even a latex balloon will survive up to like, I don't know, 0.1 psi before bursting. Am I sharing JibbyJedi?
I think we have the what is it? No, I think we're good. We have the I think the record for amateur anyway is like 160,000 feet for a balloon, if I'm not mistaken, somewhere around there. Maybe we went 170, but I've never seen footage from that high. I think the highest I've seen footage from was around 140,000. Yeah,
that's pushing. Well, you can get with the I don't know what they make them out of, poly something or other, and not latex. The latex ones don't go much above 120. But the ones that are made of that plastic stuff, it looks like saran wrap, I think you can get higher. The time is now 9:51, so we have 9 more minutes. Right. Again, this was our.
I got a question, just just things that I think about, and what the hell was it? Give me a sec. Damn it. Vacuum pressure, blah 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 blah.
So are you still like sharing? Because I think
no, I stopped sharing.
Oh, okay.
We're clean. I think we're clean. Let me check.
Because I'm just trying to go back to where it goes, like it flips the icon, globe versus Jibby.
It should be.
Okay, so yes, you have a question, and then we're going to wrap this up in about 8 minutes.
Boy, what the hell was it?
And the thing is, we could easily have more of these conversations, but I wanted to keep it to an hour just so that it's listenable.
Yeah. These marathon 8-hour debates between, people, it's crazy, right?
Right. And it's like who's going to actually watch those things, and they just get buried in dust.
We have so many hits on our little debate. I didn't want to chop it into a separate video.
Yeah. Well, it was nice that you put the index as the
Oh yeah, you did a good job breaking that down, and I feel bad for you that you had to go through all that again and listen to it.
No, it was fascinating. Especially the part where I explain exactly about curvature and how you can see curvature, how you can see the effects of curvature, and then one of your responses was, "Yeah, but I just don't understand how you can't see curvature." It's like I just spent 16 minutes explaining.
No, you explained like an explanation, like why did you come home late? You were supposed to be home an hour ago. Well, I had to stop at Billy's house, and well, that's an explanation. It's not proof. Okay. It's an explanation.
But you got to get the word proof out of your vocabulary. There is no proof.
Yes. Well, I have proof that I can see things farther than I should. And
prove to yourself, not scientific proof. Yes.
It is scientific proof because it is the scientific method to get there, and scientific evidence of a flat.
So do you want me to tackle that topic? Because that's like a real hot button topic about, how can we see that it should be hidden by 300 feet of curvature? You want me to tackle that in the next?
It should be hidden by 300 feet, but it isn't. Sure.
Right. Meaning, why can we see that lighthouse? Because if you run the numbers, it should be hidden behind the curvature of the Earth. Okay. So the irony here is that this is actually an appropriate use of perspective. So what I do is I use either the GitHub calculator, which is there's no refraction, or I use the Metabunk calculator and I ignore the bottom calculations. I just look at the top calculation where it says hidden, the hidden value. So let's say there's a lighthouse, and I'm not going to make up numbers because I don't know the numbers off the top of my head, but let's say there's a lighthouse, and let's say that lighthouse is 40 miles away. And I know that I can see that lighthouse from a certain elevation on the beach, like maybe there's a pier or something I'm standing on, and I run the numbers. And when I run the numbers, it turns out that this lighthouse, and let's say the lighthouse is 100 feet tall, I run the numbers, and the curvature calculator says that there should be 300 feet of drop, or 300 feet hidden from my vantage point, wherever elevation I am. So, and again, I'm just making this up off the top of my head. So the Earth curve calculator says that there should be 300 feet hidden Yet this lighthouse, which is only 100 feet tall, I can see, okay, from 40 miles away. Well, so you just do the subtraction and you figure, okay, so that's 200 feet. The beam of the lighthouse should be hidden by 200 feet of curvature. That's the argument. We can't live on a ball. We can't live on a globe because that lighthouse beam should be hidden by 200 feet of curvature. You're with me so far?
Makes sense.
Right?
Yeah.
Okay. Well, here's where you apply perspective. Here's where you apply perspective. You take those numbers and you put them into an angular size calculator. I'm very fond of the one, I think it's at 1728.org. But if you just type in literally angular size calculator, it's one of the first links that pops up. So you plug in the numbers. You have to convert 40 miles to feet. So because the numbers you put in the calculator have to be in the same units. So you plug in 40 miles times 5,280 feet. So whatever number of feet that is, 100,000 whatever feet. And then you plug in that the size was 200 feet of hidden by curvature, right? So I've got a 200-foot, missing curvature, and I've got this 40-mile distance, and then it will give you an angle. And that angle will always be very small. And there's your refraction right there. Again, we were just using a standard Earth curvature calculator, which is just based on geometry. It's not based on the Earth. It's just based on geometry. No refraction, right? But then you plug into the angular size calculator and you see what kind of an angle. So it's like, if I could see that lighthouse, is it that lighthouse is 0.2 of a degree away from where it should be? And it's like, that's not really a big argument, I don't know if any of that makes sense. I've got to make a video on this. I'm just explaining it verbally and I'm waving my hands around. But
well, I mean, those are little numbers. We have bigger numbers, much bigger numbers than just a little drop. You have your Beyond Horizons.
Right. Well, yeah, Beyond Horizons.
388 kilometers.
But the thing is, I've run those numbers every single time, Jibby. Oh, I'm sorry. I got to click on you.
Oh, okay. I should be presenting.
Yeah, but it was still stuck on my globe thing. So I'm clicking on you. Now you've got to wait. Okay, now it's coming up. Okay.
Yep.
And then Jibby, we gotta wrap this up in 3 minutes. But so and again, I'm gonna be happy to have more of these conversations. Whenever I've run these claims, whenever I see these claims. So one of the things you have to understand about me, Jibby, is whenever I hear claims against the globe, I actually get excited. And whenever I say, "Oh, this is the final nail in the coffin for the globe," I start rubbing my hands together. I'm like, finally, there's something I could sink my teeth into. And every single time I'm disappointed. So when I go to those Beyond Horizon, world record distance photography, and I run the numbers, like I said, I use the Earth curve calculator. I use no refraction, and then I figure out, sort of using subtraction, I figure out what the angle is. In other words, it's off by a certain number of degrees. It is always less than 0.5 degrees. Always. In fact, I think the most I've ever seen is like 0.3 degrees. Every single time it's a fraction of a degree. So it's like, if I'm looking at, Mont Blanc in France and it's, 0.3 of a degree away from where the globe says it is, like, that's not really much of an argument, But anyway.
You've seen David Weiss's drone footage of the sun winking out as it went off into the distance.
Well, yeah. I mean, anybody with a drone can see as many sunsets as you want.
But it wasn't a sunset like this. It was a sunset pretty high up. And as we claim, traveling away, like in a linear line, right. Somewhat, the light eventually, it gets swallowed up by the thickness of the atmosphere, piercing through it horizontally.
I'd have to see that footage.
Really
I just off the top of my head, I can only imagine that there was
we don't see this at all.
Cover.
None
of this. But the thing is, you don't always see that.
No, that's
the cloud cover. We got to wrap this up, Jibby. Okay. Can we talk about that in our next hangout?
Absolutely.
And I'm going to say a huge thank you to everybody who is in the chat. I'm sorry we weren't able to get to your questions, but again, this is just an informal chat between my good friend JibbyJedi and me. And you want to say any final words, Jibby?
I just want to thank all of the Globe Earth believers for being so polite in the chat and making this, Charles and I set a precedent a long time ago that it is possible for a flat earther and a glober to sit down and have an adult conversation without the hate, the cursing, the insults. We're both, we're both adults here. Let's try to work this problem out intellectually, maturely, like men, and go from there. And I don't know. I think we set a pretty good example, because I hadn't seen too many civil debates before then, and then many came afterwards. And I just want to see more of that. I want to see more civil discourse, just open talks. Like, these are, we're all humanity here.
Yes. Civil discourse is going to be the name of this chat series. So thank you, Jibby. Thank you to the people who are in the live chat, and also thank you to the future people who will comment on this video. Signing off. This is Flat Earth Math, otherwise known as Charles Breeling. Hope you have a blessed night. Good night.
Night.